Professor Rashid?
Yes.
Why should we care about Ibn al-Haytham?
It is a very long history. If you are interested in history of mathematics mainly, and then the application of mathematics in other sciences, you cannot avoid the work of Ibn al-Haytham, either in Arabic or in Latin, because you cannot understand what happened later on. For instance, if you read Kepler or read Descartes and others, and Huygens in this period, you cannot understand what they are doing, either in mathematics or in optics, without knowing what Ibn al-Haytham did.
So basically, unless we have this as a basis, it contextualizes our work today.
Yes, in a way. I mean, in a comparative way, that is from one side, and also as such. I mean, to understand how the invention of the new disciplines and new theories had been done, and how to build a new scientific generation in this kind of countries.
Ibn al-Haytham was an empiricist. He believed in looking at data, he believed in looking at phenomena, discussing it, coming out, synthesizing it, and then coming out with an idea. This is the modern scientific tradition. You predict, you observe, you discuss, you synthesize the knowledge. And Ibn al-Haytham was a master at it. He's the father of modern science, of empiricism and logical thinking, in that long before Bacon and some of the other people whom we ascribe as being modern scientists. The problem is Ibn al-Haytham, and this is quoted in the UNESCO website on Haytham, where he tells people not to just get received wisdom from teachers, question. In other words, Haytham tells people, question authority, learn to think for yourself. And unfortunately, our schools are like factories. Students come in, they take a set of exams, they graduate. They don't understand concepts. They don't understand the basics in it. They might be able to do great problems. They will know what equation to put in, but they don't understand the science behind it. See, if someone actually does something, they will remember it for the rest of their lives. But if you just listen to me, the professor, standing up, at the blackboard saying, F equals ma, they're not going to remember it for very long.
There's a great quote by an American physicist called Richard Feynman, where he said, I'd far rather have questions that can't be answered than answers that can't be questioned.
Yeah, exactly.
And I think that's a fantastic quote to explain what the scientific spirit is and what we're not teaching.
Professor Kamal, is that what we see happening at Sesame? That we have the science of Ibn al-Haytham taking shape within that project, which you're a part of in Jordan?
Yeah, exactly. Synchrotron radiation facility is simply like a circle, but inside that circle, there are lots of complexations. There are lots of optics, mechanics, geometry, electricity, engineering. So the optical systems are the basics of any synchrotron radiation facility all around the world. The idea for Sesame is actually double-wedged. One of them is to foster the excellence of science in the Middle East, and the other one is to bridge the gaps between the nations of this zone.
Using science
exactly
as a way to overcome
the political
backdrop.
Exactly.
So there's a way of scientist to scientist seeing the other as part of the solution for understanding the science and the results of our research.
Simply, there are no labels inside Sesame. So you can find on one table Arabs, Israeli, Turkish, Iranians. They are all talking with the language of science. And as much as I saw, till now, they succeed. I mean, they put everything aside, and they only talk with science, about science, and how to develop, how to grow, and how to build a community that can hopefully overcome the conflicts and to do something
Good for
rewarded.
humanity.
Yeah, good for humanity.
Good for
exactly.
humanity.
Exactly.
Right.